I remember back in Reno many years ago now, having drinks with actually Keith Blair and Doug Hartzell at the end of one of those days where we'd been working on a resource estimation study where one of the critical problems had been the reliability of the assays. And at the end of the day, we were doing that thing that people often do. Wouldn't it be great if this existed? Wouldn't it be great if the industry worked this way? If there was some kind of external monitoring, if we could log onto the internet right now and find information on how well the lab was performing. So that was when we kind of just kicked it around as a good what-if idea. And then 2 or 3 beers later, we kind of lost track of the idea. But in essence, Benchmark 6 has come from a recognition that external monitoring would be a useful additional piece of information to have whenever you're trying to sort out data reliability issues. And so we decided if that's worth having there, then we should just go ahead and implement it.
Yeah, the concept of Benchmark 6 is to produce systematic reports on a periodic basis, in this case quarterly, that facilitate direct comparison of lab performance between different facilities.
Why are we well positioned to be doing this? There's a couple different answers, I think. It's easy to be best when there's no one else doing it, and it's something that's really needed. So I think part of what we're doing is just stepping forward and saying, here's something that the industry will really benefit from the mining companies to the labs to the analysts. Everyone will be better off with this thing. And we're happy to lead that effort. We're happy to create the website, to create the reporting format, to take charge of the analysis and all that. We're happy to get collaborating mining companies lined up, but we would like to treat it as a collaborative venture. So I think part of the answer to why we're the best is because we're the first, and we've taken the initiative, and anyone else that wants to join in on that effort is welcome to work with us and make this into a good industry institution.
The lab I was managing processed up to 30 to 40,000 samples at the height of when I was managing that lab, a huge number of samples coming in on a daily basis, and obviously quality control was utmost of importance for the client. To me, as a lab manager, what you constantly struggled with was on a day-to-day basis, are you maintaining that level of quality that is essential for your client? And I think having the benchmark report is another part of the process.
I don't think you should choose a lab because of cost. I think what you look at is the reliability of your assay that you're going to get back. That there's no chance or very little chance of contamination.
The biggest challenge that a laboratory has is to have the processes set up so that the very first assay that is created for any particular sample is the result that's reported. If you cannot do it on the first assay most of the time, and I mean by like 99% of the time, then the process is flawed. And you start then introducing all kinds of problems that basically get you off track.
Problems occur all the way through the laboratory system, from sample preparation right through to the final assay. In preparation, you can have improper drying of the sample. You can have improper cleaning of the pulverizer and pressure, therefore creating contamination.
In the situation, we inserted blanks. The lab inserted blanks, and what it was we were using a certain type of equipment that the hoses it turned out when we actually went back and looked at it, the hoses that they used to purge and to clean out this crusher, the hoses were disconnected. And they couldn't remember since when the hoses were disconnected. So we had months of work sent there where we didn't know, but our blanks were kicking off, and we thought it was because, but we knew that the blanks were kicking off intermittently. And it turned out that it was because we went back to the company, the lab, and it turned out that the sample equipment that they were using, that the air hoses that were there for them to send compressed air to clean it out, weren't working for a period of time. We don't know when, so we ended up having to trash all of the information, all of the data. We trashed it. We used it. We did use it, but we didn't use it quantitatively. We used it qualitatively. So that shouldn't happen.
You can have sample mix-ups. You can have inadequate attention to obtaining representative samples when you're sample splitting.
We were doing exploration drilling in a project area. We got a bunch of low-grade results in an area that we were told was barren. There was no gold. But the fact that there was low-grade results in this area, we looked at that and said, we should. There's some anomalies here. Maybe we should drill some more holes here. There's some low grade. Maybe we're onto something. And it turned out that when we were investigating it, our geologist said, Mark, we've looked at this area before. There's something wrong with this information, this data. There's something wrong. We need to look at it again. And when we looked into it, we found out that it was a problem of contamination that we couldn't have picked up. We were sending samples, just samples, routine samples. We didn't have any quality control. We had blanks that the lab inserted. We thought that was okay. Turned out that the contamination wasn't at the crushing level or the sample preparation level. The contamination was right in the crucible level. They were using used crucibles.
Assay section, you can have a poorly calibrated assaying unit. You can have inconsistent digestion of the sample, miscalculation of dilution, and of course reporting errors.